A red dwarf will take up to 30 billion years to use up its hydrogen. Then it should cool down and become a cold ball of gas known as a black dwarf. Yellow stars, such as our Sun, last about 10 billion years. It is about 5 billion years old now. In about 5 billion years' time, the Sun will have used up all the hydrogen. Then it will begin a new fusion process using helium. When this happens, watch out. The Sun's diameter will expand 100 times, engulfing the inner planets, including the Earth. It will become what is known as a red giant. After a few million years, it will use up the helium and then blow its gas out into space as a powerful solar wind. The remaining cinder, smaller than the Earth, is called a white dwarf. Our galaxy is littered with the remains of exploding sun-sized stars. White stars burn fuel much faster. They fuse hydrogen, then helium, then other elements in turn until they too become white dwarfs. When a massive blue star has converted all its core hydrogen into helium, it cools, and gravity pulls the surrounding gases into the center. Compression then heats the core temperature to 170 million degrees. The outer layers of the star now expand to about 100 times their original diameter. The star becomes a red supergiant. In the core, new reactions take place. Hydrogen is fused to helium, then to other elements. Eventually, the star is layered like an onion. Iron atoms cannot fuse together, so the reaction stops abruptly. The heat ceases, causing the outer layers of the star to collapse. They rush in, compressing everything. Then the star bounces back in an incredible explosion called a supernova. For a short time, supernovae can be so bright they outshine an entire galaxy. Heavy elements are made in the supernova, and these form rock and planets, and even living beings. In the center of the remains of a supernova is a neutron star. This is the remains of a supernova 1987A in the Large Magellanic Cloud. The neutron star is in the center. Neutron stars are made up of neutrons and are only 20 kilometers or so in diameter. They are incredibly dense. A single teaspoonful of neutrons weighs millions of tons. Some neutron stars are known to pulse radio waves and are called pulsars. The supernova remnant, known as the Crab Nebula, has a neutron star at its center. It pulses 30 times per second. These pulsars have immensely powerful magnetic fields. These rotate extremely quickly, and when the beam points towards the Earth, our radio telescopes detect their pulses. The biggest of the supernovae squeezes the matter in the center so much that it disappears and a black hole forms. Nothing can escape a black hole, even light, which is why it is black. The zone at which light is consumed by a black hole is called the event horizon. And if you were to fall through, your body would be stretched like a rubber band as you fell. This picture from the Hubble Space Telescope shows what is thought to be a huge black hole in the center of an elliptical galaxy. It is swallowing millions of stars. Most stars vary their intensity over time. The Sun varies a little every 11 years. Some stars vary their brightness a great deal and for shorter time periods. Cepheid variables are extremely bright supergiant stars, and their brightness varies over a matter of days. Most stars in the Milky Way belong to multiple systems, that is, 2 or more stars in mutual orbit. Usually 2. Sometimes one of the stars is duller than the other. If they are lined up conveniently, we see the dull star pass in front of its neighbor, and the bright star will appear to dim. Our nearest stellar neighbor is a triple system. If the stars of a binary system are about the same size, they will revolve about a mutual center of gravity. But if one member is larger than the other, then the center of gravity is closer to the larger star. This is what our solar system would have been like if Jupiter had been a lot larger and become a star. The more stars a system has, the less stable the orbits tend to be, and systems with 4 or more stars are likely to fly apart. Any planet belonging to a multiple star system would have a very chaotic and unpredictable orbit. Sometimes a star is unlucky enough to be orbiting with a black hole. The black hole pulls matter off the star, and we can see this happening because gases give off X-rays as they fall in. Such a system is Cygnus X1, which is thought to be a blue supergiant orbiting a black hole. Originally, the black hole was an even more massive star than its companion, but it used up its nuclear fuel more quickly and became a supernova, leaving a black hole behind. The rapidly spinning black hole is cannibalizing the remaining star. So next time you raise your eyes to the heaven, you will see a universe with countless billions of stars, all converting the simple gas hydrogen into the elements that make up the world we know. They are building and supporting life on this world, and probably others.